Hi everyone, in this video we're going to see if we can figure out the value of tangent of a sum. So we have formulas for sine and cosine, but this one is asking us for tangent. Okay, so we are given some information to get us started. We know that alpha and beta end in quadrants 1 and 3. So alpha in quadrant 1, beta in quadrant 3. We also know that sine of alpha is 2/7. So alpha is in quadrant 1 with a y-coordinate of 2/7. Okay, so we'll say this is our alpha. Actually, alpha could be infinitely many. This doesn't specify. But this is the point at the end of alpha for sure. And then beta ends in quadrant 3, and we know cotangent of beta is 1/3. So that's a slope. So if we picture a slope of 1/3, this is the point that we're looking for at the end of beta. So beta is the arc length, but we don't know exactly what that looks like, just where it ends. Okay, so we want to find tangent of alpha plus beta. And here's the thing, there are formulas for tangent of a sum, just like there are formulas for sine and cosine of a sum, but I think at some point it gets to be formula overload. So I would say let's use the formulas we already know. We know that tangent of an angle is the same as sine of that angle divided by cosine of that angle. So we can actually use the formulas that we started with to say that tangent of alpha plus beta is going to equal sine of alpha plus beta. Let's see where I ditched my formulas sheet for you. So sine of alpha plus beta is going to give us sine alpha cosine beta plus cosine alpha sine beta. Okay, so we're going to start with a sine alpha cosine beta plus cosine alpha sine beta. And then cosine of a sum, cosine of alpha plus beta, is going to give us cosine alpha cosine beta, and then it was a plus, so it'll switch to a minus, sine alpha sine beta. Okay, so we need a lot of information, and we do have some of it. We know that sine alpha is 2/7, and we know that we don't know sine or cosine of beta. So let's go start some of that work. So here we can fill in 2 spots, and that's about it right now. Okay, so if we work on alpha first, we know that alpha has a y-coordinate of 2/7, which means, let's go ahead and do a little scratch work. X squared plus 4/49 equals 1. So x squared is 45/49, which means that x is plus or minus root 45/7. Alpha was in quadrant 1, so we're going to choose the plus. So this is a root 45/7. And over here, we can fill in the cosine alphas with that number. 7. Okay, and then we don't know sines. Cosine alpha. Okay, so right here as well, root 45/7. Okay. So now we need to work on beta a little bit. And beta, we were just given cotangent. So all we can say for beta is that x over y is equal to 1/3, and also that x squared plus y squared equals 1. So I would say solve this. That means that x is equal to 1/3 y, or y/3, and then substitute. So if we square that, we get a y squared over 9 plus a y squared equals 1. And personally, I think I'd clear the fraction. So if you multiply both sides by 9, the 9 under here cancels out. We get a 9y squared and a 9. So 10y squared equals 9, which means that y squared is 9/10. which means that y is plus or minus 3 over root 10. Oh, there we go. Barely snuck off the bottom. Okay, so beta, I'm not fitting everything on one page. Let me scoot back. Beta was in quadrant 3, so I'm going to choose the negative y, and that's going to go in wherever I had sine beta. So negative 3 over root 10, and then sine beta down here, negative 3 over root 10. Do not try to cancel those. Yes, I do see multiplication, but the big operation is the addition subtraction. So we can't use division to get rid of addition subtraction here, which is the important operation. Okay, and then we also need our x value, but that's actually easily gotten from this formula. We know that x is, so I guess I'm going to change it. I'm going to say 1/3 y, even though I wrote it y over 3, because that'll be easier to multiply by negative 3 over root 10. So the 3's cancel, and I get that x is negative 1 over root 10. Okay, so that's for beta. So that's going to replace all the cosine betas. Negative 1 over root 10, negative 1 over root 10. Okay, so that was all my Pythagorean theorem side work. Again, you got lots of mini problems in here, but like I said, just embrace it. It's really good review practice. So it's using a formula and then reviewing all these little bits and pieces. I do have to do a little bit more to simplify this than usual. So I'm going to multiply together and say I have a negative 2 over 7 root 10. And then minus 3 root 45 over 7 root 10. And then on the bottom, I have root 45 over 7 root 10 plus 6 over 7 root 10. Okay, so there's just the multiplying some of those internal fractions. And then I'm going to rewrite this as a single big fraction on the top and a single big fraction on the bottom. So root 45 plus 6 over 7 root 10. Okay, and then almost there. What happens is we're dividing fractions, so we end up having to multiply by the reciprocal. So that gets rid of the denominator. So flip and multiply. And conveniently, that means that the 7 root 10s actually go away altogether. So we're left with negative 2 minus 3 root 45 over root 45 plus 6. So I do want you to clear out the fractions and fractions. You don't have to do anything else from there. If you do any additional simplification, you could check these answers by plugging them into your calculator. So I don't want to see the decimal, but you can use it to help you check. So that was really messy, but what we just discovered is that if we know everything about the points at the end of arc lengths alpha and beta, we can find the slope that passes, the slope of the line that passes through the point at the end of arc length alpha plus beta. Okay, thanks for watching.